Hey everyone, in this tutorial series, you'll learn how to create a third-person parkour system in Unity, and you'll also learn lots of important gameplay programming concepts while creating it. So we'll create an advanced third-person character like this that can traverse dynamic environments with parkour. It's a really common feature in modern-day games like Assassin's Creed, Watch Dogs, etc. But the mechanic itself has been there in lots of older games like Zelda Ocarina of Time. So it's a perfect project for learning core game programming skills. So let's look at what all we'll cover in the series. We'll start by creating an environment scanner for detecting obstacles in front of the player, and then we'll make the player perform different parkour actions dynamically based on the height and type of the obstacle. We'll also look at advanced animation techniques like target matching that will allow us to adapt the same animation on obstacles of different height. So here you can see that the player is performing the same parkour animation on obstacles of different height. So yeah, that's done by using a technique called target matching. We'll also be architecting the parkour actions using scriptable objects to make them designer friendly so that designers can easily create and update parkour actions without touching the code. So we'll cover all this in the series. By the way, this series is one of the modules from our Unity Parkour and Climbing System course on Udemy. The course has more modules that covers features like climbing system, ledge movement, etc. I'll leave a link to the full course in the description if you want to check it out. Also, we have an advanced parkour and climbing system asset on Unity's asset store. It's an out-of-the-box system with which you can set up parkour and climbing mechanics in your game in just a few minutes. It comes with lots of advanced features like predictive jumps, procedural climbing, balancing on narrow obstacles, swinging on bars, etc. So be sure to check it out if you want a complete system to integrate in your games without building it from scratch. I'll leave a link to it in the description. The asset also comes with the entire source code, so if you want, you can also review the code and learn how each feature is implemented. Alright, so with that, let's start the video. So first we'll create a Unity project and set up a scene in which we can build our parkour system. So I have my Unity hub opened over here. So I'll click on the new button to create a new project. So let me just name this something like Parkour System course. All right. And I'll change the template to Universal Render Pipeline, just in case you want to use the shader graph or the VFX graph in the future. All right. So let me go ahead and hit the create button and it should create the project for us. So this will take some time. So I'll pause the video and get back to you once it's over. All right. So the project has been created. So the URP project comes with some example assets. So we don't need them. We're going to build everything from scratch. So let me go ahead and delete the example assets. And I'll also delete the folder containing the example assets. Okay. And then we can also delete the tutorial info and the README file. We don't need them. So next, let's create a new scene. So inside the scenes folder, we already have a scene over here, but I want to create a new one. So I'll go to create and select scene to create a new scene. So let me just name this something like test scene. And I'll double click to open it. So here I'll add a new plane game object. So under 3D object, I'll select plane. So this will act as the ground of our scene. All right. So let me just reset its position so that it's at the center. And I also want to make this plane a little bigger. So I'll change the X and Z scale to something like 5. All right. We have a much bigger plane. So next, I want to change the material of the plane. If we use a plain material like this, then it will be hard to understand if our character is moving or not. So let me create a new material for this. So under the materials folder, I'll right click
and create a new material. So I'll call this material checkers. All right. And under the surface input, we can change the texture of the material. So if you click on the base map, you can select the texture that you want to use. So I'll just use this default checkers texture that comes with Unity. All right. So now we can drag and drop this material to the plane to apply it. So it's applied now, but the checkers are a bit big. So I'll increase the tiling to 10 to make the checkers small. So that looks good. So now we have set up the scene to work with.
So next, since we're going to build a third-person parkour system, first we need to create a simple third-person controller that can just walk and run. So I've already made a free tutorial that covers how to make a third-person controller from scratch. So I'll be using that third-person controller as a starting point for building our parkour system. I'll leave a link to that third-person controller in the description so that you can download it for free and follow along the series. But if you're a beginner and if you have never built a third-person controller from scratch, then I highly recommend you to watch the third-person controller tutorial and build the third-person controller from scratch. In that tutorial, I've covered lots of basic Unity concepts like how to use Unity's character controller, how to implement camera relative movement, how to use humanoid retargeting to reuse same animations on multiple characters, how to use physics for detecting ground, and all that. So if you're not familiar with those concepts, it'll be hard for you to follow along this series because in this series, we'll be building on top of all that. So yeah, I highly recommend you watch the third person controller tutorial. But if you are an intermediate level Unity developer who knows these concepts, then you can just download the third person controller project and just follow along the series. You don't have to build it from scratch. All right. So once you download the third person controller using the link in the description, you'll get a Unity package file like this. So you'll have to import this package into your Unity project. So here, I'll drag and drop the third person controller package into the assets folder. All right. And it'll show a small window like this in which we can select the things that we want to import. So in this case, we want to import all these files. So I'll just click on the import button. All right, so it has imported the third person controller and all the animations, models, and scripts needed for it. So the actual third person controller will be in the game folder. So this prefab is the third person controller. So we can just drag and drop it into our scene. All right. And to make the camera follow our player, we have to attach a camera controller script to it. So that script will come with the third person controller. So let me go ahead and attach it onto our main camera. All right. So in the camera controller, we have to attach the follow target, which is the target that the camera will follow. So in our case, it's the player. So I'll drag and drop the player over here. And I'll also make some adjustments in these values. So first I'll change the Y value of framing offset to 1 so that the camera will look towards the neck or chest part of the player instead of looking at the feet. And I also like to invert the y-axis of my camera. So I'll check invert y. So the script was created in the third person controller tutorial. So if you don't know what any of these parameters are, then go ahead and watch the third person controller tutorial once again. So now let me try testing the third person controller. All right. So the camera is working fine. And the character is also moving related to the camera. Okay. And by the way, let me just reduce this angle so that we won't go below the ground. So in the camera controller, I'll change the min vertical angle to something smaller like -10. Again, all these things were explained in the third-person controller tutorial. So now if we test again, the camera should not go below this point. All right. So now we have a basic third-person controller. So this third-person controller will also detect collisions with other objects. So if we add a collider in the scene, the player wouldn't walk through it. All right, so let me add a cube in a scene to test that. So I'll just make it a bit bigger. And now if we test, you can see that the player is not able to walk through the cube. All right, so the collisions are working. So next I'll check if the gravity is working. So I'll just place the player at a height above the ground. All right, so now when we play the game, you can see that the player is falling down. So the gravity is working. We can also try placing the player above our cube just to see how the player falls from it. So now when we run the game, the player will first fall onto the cube and we'll be able to walk on the cube. But when we walk out of the cube, the player will fall down to the ground. All right. So things like collisions, gravity, and all that are working. So now we have a basic third-person controller as our starting point. Again, you can build this from scratch by following the third-person controller tutorial, or you can just download it and set it up like this, like I did. So now, since we have a third-person controller, we can start building our parkour system on top of it. So first, let's create some cubes of different height in our scene so that we can test different parkour actions. So when I work on adding and placing items in the scene view, I want it to be a little bigger. So what I usually do is I close all the unwanted tabs and let me just place the project tab over here. So now I have a bigger scene view and I can work much more easily. So we need to add few cubes over here. So first, I'll add an empty game object called environment. All right. So this will be the parent game object to all the obstacles in the scene. So let me just reset its position and let me move the plane under the environment game object. And we don't need the old cube. So let me go ahead and delete that. So now let's create some new cubes that will act as our obstacle. So let me go ahead and add a cube over here. All right. So I'll set its X and Z scale to 3. So that is a little more bigger. So we want to create cubes of different height. So the first one will be of height 0.5. So let me change the Y scale of it to 0.5. All right. And we want to place it on the ground properly. So if you want to place it perfectly, we can set the Y position to 0.5 by 2, which is 0.25. So now the bottom of the cube should be placed on the ground perfectly. All right. So let me just move this cube over here because we have more cubes to add. So I'll duplicate this cube by pressing Ctrl D to create the second cube. So the second cube will be a little more higher. So I'll change its Y scale to 0.75 and I'll make its Y position 0.75 divided by 2 so that the cube is perfectly placed on the ground. Okay. So next I want to snap this cube to this one. So we can do that by using vertex snapping. So first I'll click on the cube and then I'll press and hold the V button. So when we hold the V button, it will allow us to select different vertex from the cube. So let me just select this bottom vertex. And if we drag this vertex towards this cube, then it will automatically snap with it. All right.
So this is just a technique if you want to perfectly snap the objects in your scene. So next, let me create another cube. So the height of this one will be 1, and let me change the position to 1 by 2, which is 0.5. All right, and let me also snap it like this. Okay, so now let me duplicate this and create another cube of height 1.5, and I'll set its Y position to 1.5 by 2, which is 0.75, and let me also snap it to the other cube. All right, so next let me duplicate this and create two new cubes of height 2 and 2.5. All right, so now we have cubes of different height. So next we can start building our parkour system. So the parkour system is going to consist of two components, the parkour controller and the environment scanner. So the environment scanner will be responsible for scanning obstacles in front of the player, and the parkour controller will perform the parkour action based on the data of the obstacle detected by the environment scanner. So first, let's add the environment scanner script. So let me just switch back to the default layout. So we can do that by going to layouts and selecting default. All right. So now let's go to the scripts folder and let's create the environment script. So here I'll create a new folder called Parkour System. And by the way, let me move these two scripts into another folder called Third-Person Controller. All right. I like to keep my scripts organized. So now in the Parkour System folder, I'll create a new script called Environment Scanner. All right, let me open this up in Visual Studio and get rid of the default code. So in this script, we need to create a function to scan for obstacles. So I'll create a public function called obstacle check. So in this function, first I need to do the forward raycast to check if there is any obstacle in front of the player. So we can do a raycast by using physics.raycast function. So this function has lots of overloads. So here you can see it has 16 overloads, right? There are just so many combination of parameters that we can pass to this function. So the overload I'm going to use is the 15th one because I want to pass all these parameters. So the first parameter that we want to pass is the origin of the ray. So I want the ray to start from around the knee height of the player. So transform.position will give us the feet position of the player. But I want the origin to be a bit more higher. So we can just add an offset in the Y direction. So I'll just add an offset like 2.5. Okay. And we don't want to hard code the offset value like this. Let's make it a serialized field variable so that we can change it from the inspector. So I'll create a vector3 variable and I'll call it forward ray offset. Right. And let me just give it a default value of 2.5 in the Y direction. So now we can use this variable as the offset. All right. So let me go back to the 15th overload of this function. And by the way, in case you didn't know, you can change the overload versions of the function by using the up and down arrow keys. So I'll go to the 15th version because that's what we need. So next, In the second parameter, we have to pass the direction of the raycast. So I want this ray to go in the forward direction. So I'll pass transform dot forward for the direction. All right. So for the next parameter, so the next parameter is actually an out parameter. So here you can see that there is out written in front of this parameter. So this parameter is actually a special type of parameter called output parameter. So let me explain what it is. So usually when we pass a parameter to a function, we do it to give some value as an input to the function, right? But the out parameter is the opposite. It's not used to pass a value as an input. It's used to retrieve or output some value from the function. All right. So in this case, it's used to retrieve the hit info of the raycast. So we have to create a variable of type raycast hit. All right, let me just call it hit info. And we have to pass it as a parameter to the function. All right. And when we pass the parameter, we also have to add the out keyword at the start. So this is how you pass an output parameter in C#. So this will output the value of hit info to this variable. All right. And by the way, there is actually a shorter way of writing this. We don't have to define the variable above the function like this. Let me just get rid of that. We can define the variable here itself. So after the output keyword, I can just write the variable type, and this will retrieve the hit info just like before. All right. So I like to define it like this since this is shorter. So for the next parameter, we should pass the distance of the raycast. So let me create a serialized field variable for the distance so that we can set it from the inspector. So I'll create a float variable called forward ray length. And let me just set it to something like 0.8 by default. So we can pass that as the distance or the length of the ray. Okay. And finally, we also need to pass the layer mask. So the layer mask is optional, but passing a layer mask will allow us to improve the performance of the raycast. So let me also create a serialized field variable to store the layer mask. So I'll call this obstacle layer, and I'll pass it as the final parameter of the raycast. Okay, so we have so many parameters in this function. So let me just clean this up because I don't like long lengths of code. All right. So the raycast function will return a boolean that indicates if the ray has found a hit or not. So let me store the return value in a variable called hit found. All right. So this line will do the forward raycast for us. So I want to visualize this raycast by drawing a line. So we can do that by using debug.drawRay function. So to this ray, again, we have to pass the origin. So let me actually store the origin in another variable so that we can reuse it. So I'll create a variable called forward origin. All right. And let me use it over here. And I'll also use it as the origin of the drawRay function. All right. So next, we need to pass the direction of the ray. So the direction is transform.forward. And while passing the direction, we should also multiply it with the length. So let me multiply it with the forward length. So this is because the debug.drawRay function doesn't have another parameter to take the length like the raycast function. So we have to multiply it with the direction. All right. So finally, we can pass the color of the ray, which is actually an optional parameter. So what I'll do is, if the ray did hit an obstacle, then I'll change its color to red, and otherwise, I'll just make the color white. So if the ray did hit an obstacle, then the hit found variable will be true. So if hit found is true, then I'll return red for the color, and otherwise I'll return white. Okay, so we have to add a question mark after the condition. So this will allow us to visualize the raycast. So now let's call this function and test if the raycast is working properly. So we'll be calling this function from the Parkour controller script as I previously explained. So let's actually go ahead and create the Parkour controller script. All right. So let me open it and get rid of the default code. So in the script, first we need to cache a reference to the environment scanner. So let me cache a reference from the awake function. All right. And then from the update function, we can call the obstacle check function of the environment scanner to check for obstacles. So I'll call environment scanner dot obstacle check. So next, let's attach these two scripts to our player and test if the raycast is working. So first I'll assign the Parkour controller script, and then I'll assign the environment scanner script. All right, so these values should be fine, but we have to assign the obstacle layer. So let me go ahead and select the obstacles layer. And then we also have to make sure to set the layer of all the cube to obstacles. Only then the raycast hit will be registered. All right. So now let's go ahead and test if the raycast hit is working. Let me just bring the player down. And let's go ahead and test. Okay. So when I run the game, we can see the forward raycast. But right now, we are casting it from above the player's head. So I think we have given a wrong value for the forward ray offset. All right, so here I've set the y of the forward ray offset as 2.5. So that's really high. So I'll make this something small like 0.25. Okay. So now when we test, the forward ray cast is casted from around the knee height. Okay, so that's perfect. And if we go in front of an obstacle and if the ray cast hits an obstacle, then it'll turn red. Okay, so it's white when there is no hit and it's red when it hits an obstacle. So that's working fine. So next, from the obstacle check function, we should return details like the hit info and whether the hit was found or not, so that when we call this function from the Parkour controller, we can use these details to check if the player should perform an action or not. All right. So let's return these details from the obstacle check function. So here, I'll create a new struct called obstacle hit data. All right, so I'm using a struct instead of a class because this is just a data container that's not going to have any functionalities. All right. So in this struct, first I'll create a public variable called forward hit found. Okay. And next we need to create an object for the hit info. So here I'll create a public variable of type raycast hit, and I'll call this forward hit. Okay, so now from the obstacle check function, we can return obstacle hit data. So at the start of this function, I'll create an instance of the obstacle hit data struct. Okay, and the hit found should be stored in hit data dot forward hit found. All right, and here also we should use hit data dot forward hit found. So next, to store the hit info in the forward hit object, we can pass it in the out parameter. So here I'll pass hit data dot forward hit. Okay, and at the end of the function, I'll return the hit data. So now when calling the obstacle check from the parkour controller, it will return the hit data. Okay, and from the hit data, we can check if there was an obstacle in front of us or not. All right, so we can just check the value of hit data dot forward hit found. So if that's true, then that means there's an obstacle in front of us. So in that case, we should perform a parkour action. But for now, let's just write debug.log and make sure that it's working fine. We'll be implementing the parkour actions in a future video. Okay, so here I'll say obstacle found, and I'll also print the name of the obstacle game object. So we can get that from hit data dot forward hit dot transform dot name. Okay, so now let's go ahead and test this. So if I go in front of an obstacle, you can see that in the console we have a message saying that obstacle found, and it also shows the name of the obstacle, right? The name is cube 3 in this case. Okay, and if I go to the next one, it'll be different. It's cube 4. So we have built an environment scanner that can detect obstacles in front of the player. Okay, so I'll stop the video here, and in the next video we'll use another raycast to find the height of the obstacle. We need the height of the obstacle because it'll help us to decide which parkour action to perform on an obstacle. So we'll be doing that in the next video. Thanks a lot for watching. If you find this video helpful, please make sure to leave a like on the video. That will really help me out. So I'll see you in the next video.